One, two, three.
1, 2, 3.
Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ, Narre Warren South, on this 8th of March. A very pleasant good evening to everybody that's tuning in to the session tonight. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3 RTV, digital channel 1, evening viewers, and also on my YouTube stream, which you can find by typing in VK3CSJ into the YouTube search engine. Look for the live symbol. And I think we also have an email address, vk3ekh at gmail.com, vk3ekh at gmail.com, and a Discord channel, which I have forgotten to bring my computer across to look at. I'll have to do that in a moment. Very pleasant good evening. I trust everybody is well, and on this hot weekend coming up. The Astronomical Society of Victoria, founded in 1922, comprises well over 1,600 members throughout Victoria, the other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, coming up next Wednesday in fact, the latter being held on a Saturday night, except in January. Meetings start at 8 p.m. at the Mullier Hall, Burwood Avenue, Melbourne near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. These monthly meetings are also broadcast on the ASV's YouTube channel and the Foxtel via the Foxtel via the Facebook channel on ASV Facebook page. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try before they buy. It's the ASV loan scheme. You have to be a member to be able to do that, of course. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two, only with appropriate training. These range from 300mm to 1000mm in aperture. Also located on the side is a fully steerable 8.5 metre radio telescope, which members can access with involvement through the radio astronomy section. A very pleasant evening to any RAS members that might be watching and listening. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. There are other areas of interest that members can participate in, include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook. However, further information may be obtained by visiting the ASV's website and at www.asv.org.au. www.asv.org.au. Notifications of events are also given in the Crux Extra bulletins, which are a alternative information device sent out via email to members every other week. And please note that ASV will contain, as in conform to all government health directives, ASV events may be required to be cancelled, moved or postponed. And I haven't really seen the notice go out at this stage, but I understand that there's a fire ban, a total fire ban tomorrow, which could mean, I don't know at this stage, but could mean that the LMDSS might be off limits. I haven't seen a notice on that one yet, so keep an eye open on the ASV website for that one. All right. Yes, so there it is. I think I was going to go to... Oh, yes, that's right. And as I mentioned, there are monthly... Oops, what are you doing? Monthly meetings. ASV's monthly meeting is this Wednesday coming up. And actually, that's not the slide I want to put up. This is the slide that I wanted to put up for this Wednesday meeting. A crash course into galaxies is what's going to be discussed next Wednesday night at 8 o'clock. And like I say, you can either pop into the Mullier Hall, the National Herbarium, and sit down there. I think they want to increase their numbers of actual attendees. So if you're not doing anything on Wednesday night, go along to the ASV meeting at the Herbarium. But otherwise, like I say, they're going to be presenting this on YouTube and the Facebook page as well. And I do have a breakdown of this, courtesy of Mark, the President. Our Milky Way is our stellar neighbourhood. This giant galaxy contains almost all of the stars and planets we can see with our eyes from Earth, but it's not the only one. There are thousands upon thousands of galaxies in the observable universe, and we keep finding new ones. Furthermore, our own galaxy is on a collision course with Andromeda, its nearest neighbour. What will happen when these galaxies collide? Has this ever happened to the Milky Way before? Have we ever seen other galaxies crashing into each other? Tune in to this presentation to learn the answers to these questions and much more next Wednesday evening. A little bit of blurb on the presenter, Antonia is her name. I'm not sure of a surname, can't see a surname there. Oh yeah, there it is, Antonia Fernandez. Antonia Fernandez, I think that's how you pronounce him. Antonia is a PhD candidate at the Swinburne University of Technology. Her research is centred in the study of the gas surrounding galaxies, also known as the circumgalactic medium. Besides her research work, Antonia is an active science communicator. In Australia, she has worked as part of the outreach team in her university and as a mentor for high school students participating in the Swinburne Youth Space Innovation Challenge. And she has also given multiple talks and lectures for the general public. You'll see her in live format next Wednesday evening at 8 o'clock at the Melbourne Planetarium. That is in the Herbarium. That's what I was trying to say. The National Herbarium at Mullier Hall would be the best way to go, or you can see via the YouTube stream or the Facebook stream. So and of course it'll be recorded. So once the program is finished, you'll be able to catch up with it again at a later time, if that's the way things work out. So that should be a most entertaining presentation, I would say. Okay, so the next thing I was going to talk about briefly, is just go over, for those that weren't around last week and missed the Sky Notes, I'm just going to go quickly through them, just a summary of what's up in March this moment. The autumn equinox is slated for Wednesday the 20th. We reach the equinox with equal lengths of day and night. Autumn equinox in the southern hemisphere and the spring or vernal equinox in the northern hemisphere. We are midway between summer and winter solstices, and our planet's axis leans neither toward nor away from the sun that day. Sunrise from Monday the 11th is 7:14 a.m, setting at 7:45 p.m. And by the end of the month, 29th, it'll be rising at 7:33 a.m, setting at 7:14 p.m. Moon phases. There is a new moon on Sunday the 10th, a first quarter on the 17th, and a full moon on the 25th. Mercury has had its solar conjunction, but still too close to the sun to view this month. Venus is still visible in the early morning, low in the east, but is moving closer to the Sun for solar conjunction. It can be seen this month from around 5:20 a.m. and a little earlier each morning before it fades in the morning light. Mars is now visible again, returning to our morning skies after its passage behind the Sun. It is visible around 4 a.m., rising before Venus. Jupiter is soon to pass behind the Sun, but remains visible low in the northwest around 8 p.m. before setting by 10 p.m. Saturn, after its solar conjunction, is still too close to the Sun, sitting below the eastern horizon at sunrise. However, by late March it will begin to appear in the east before sunrise, below Venus, and gradually ascending past Venus as the planet descends. A planetary lineup. Looking for a date quickly. 15th of March. 15th of March, 5:30 a.m. Enjoy the sight of 3 planets moving positions this month in the east before dawn. An extended triple lineup occurs in March with Mars, Venus and Saturn. If you observe over the second half of March, you will see Saturn day by day ascend and overtake Venus, while Venus descends to the horizon. Meteors, the Gamma Normids. Meteors peak around 15th of the month. They are centered near the star Gamma Normae, the third brightest star in Norma. Constellation the Level, which lies between Scorpius and Centaurus. They are a minor shower and would be best to look from midnight to dawn from a dark sky location. Gamma Normids, 15th of the month. Do we worry about this? Let's not worry about this. International Space Station. If you're interested in catching up with the orbit of the International Space Station, just go to heavensabove.com. Heavensabove.com gives you the position of just about any celestial object, satellite in orbit, including SpaceX, Starlink satellites. Which reminds me, if you're interested in looking out for the SpaceX train, the satellite train that goes across the sky from the odd occasion when they get launched for the first time, there is a website that you can go to. It's called findstarlink.com. Just simply find Starlink, or one word, findstarlink.com. And you'll be presented with a simple page where you place in your country and your location, and click on Find Visible Times, and give you an idea of when to be able to look out for these trains that go across the sky when they first get launched. Okay, and I've gone through all those dates, so I shan't worry about them. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. My taskbar is doing something funny. I don't know why. It's got the jitters. It's doing something funny. I don't think it's causing me any issues. It's like there's something caught on the keyboard here, but there's nothing on the keyboard to worry about. But it's doing this nervous twitch thing. So I'm not sure. Maybe it's RF getting into the monitor. Okay. First article for tonight at 10:16. Why are there no green stars? Have you ever noticed that? I can't say that I've particularly noticed it, but why are there no green stars? Because of the way our eyes see combinations of frequencies of light, green can never dominate the colour of a star. That's what it says here. Green can never dominate the colour of a star. It's interesting, because I know that the frequency response of the human eye, if you want to call it that, is around that green part of the spectrum. So it's interesting. Anyway, what's the article say here? It's one of these Ask Astro articles from astronomy.com. At least I think it is. Anyway, so on the colour wavelength spectrum, green falls between yellow and blue. Why are there no green stars? Says Jeff Franklin from Arizona. This is an excellent question, and seems weird, right? The colour of stars, or anything that gets really hot, is connected to its temperature. This is because hot objects emit light, which is called thermal radiation. The colour of this light, or in physical terms, its frequency, depends on the temperature. As any object gets hotter, it emits more and more of its light at higher frequencies. The same way, it takes you more energy to jump at a faster rate. It takes more energy to emit light at higher frequencies. These higher frequencies appear blue to our eyes, while lower frequencies appear red. So as an object gets hotter, it generally gets bluer. As a result, the hottest stars appear to us as blue, but cooler stars appear red. There's a picture here too I'll bring up. It's associated with this article. Right back to the article. So why can't stars with temperatures in between appear green? The answer is a result of the way our eyes see combinations of frequencies. Our eyes add up all the colours that come in, and the colour we see is the result of this addition. Green is a very specific frequency, but stars emit light smoothly across a broad spectrum. Think of this spectrum like a playground seesaw with a rainbow painted on it. Blue on one end and red on the other. This seesaw tilts based on temperature, and the colour we see is a mixture of all the colours on the seesaw. Here's the trick, though. We see more of whichever colours are higher off the ground. If a star is really hot, the blue end is tilted up, so blue dominates over the other colours, and we see the star as blue. If it's cool and the red end is tilted up, red dominates, and we see the star as red. On a seesaw, you can't make this middle any higher than the ends. If the temperature is moderate so that we are in the middle of the board, then the board remains horizontal and we have to add up all the colours equally, which comes out as white. In fact, that's why our own sun is white. Its temperature corresponds to a frequency in the middle of the seesaw. Green is also near the middle of the seesaw, but there is just no way to tilt the seesaw to make green higher than any other colour. Our only options are blue, white or red. And the star you're seeing in the screen there is the double star Albireo in Cygnus. Shows off a beautiful contrasting colours of orange and blue, which also reveal the star's differing temperatures. I think you can see that on the screen there. Well, that was interesting, wasn't it? I thought it was interesting. You're tuned to ASV Radio. Oh, that's the wrong one. vMix. Go back to vMix and select the camera, Clint. There we go. Okay, our YouTube stream is still hanging in there. Every week, I'm pleased about that. All right, you're tuned to ASV Radio, VK3EKH, broadcasting on 3541 kilohertz, SSB, and on the Melbourne television repeater VK3R2V in full HT and YouTube. Mars Juno spacecraft probe Europa oxygen levels. The icy moon hosts a liquid ocean and produces 26 pounds of oxygen each second. Did you know that about Europa? The icy moon hosts a liquid ocean. We know that much. That's what they've been saying for a long time now. Well, what I didn't know, it produces 26 pounds of oxygen each second. But is that enough to support life, you might ask? And of course we have a picture of Europa here, so I'm going to swing that into the view right now. And I might just bring this up as well. There's me. A little pop in there. I always like that, doing that. So the article goes on to say that Europa, it's my dyslexia kicking in again. Europa, one of the Jupiter's Galilean moons, hosts a liquid ocean beneath a frozen shell. Because of its proximity to Jupiter, the moon is constantly hit with radiation that erodes its icy surface, releasing hydrogen and oxygen in the form of an atmosphere, and provides a possible way for oxygen to seep back into the ocean, making it potentially habitable. Blah, 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 blah. However, the amount of oxygen produced this way was only. That's what it says there. However, the amount of oxygen produced this way was only previously inferred. Now, new results published March 4 in Nature Astronomy and based on direct measurement show there is less oxygen produced on Europa's surface than previously thought. About 26 pounds or 12 kilograms of oxygen every second. That's enough daily oxygen to support 1 million humans. Based on previous evidence, researchers thought that anywhere between 11 and 2,425 pounds, or 5 to 1,100 kilograms, were produced each second. The new result, at the lower end of the range, may reduce the chances of Europa's underground ocean supporting life, they reckon. Researchers analysed data collected by the Jovian Auroral Distribution Experiment, or JADE, aboard the Juno spacecraft to see just how much oxygen is released from the surface. In September 2022, Juno skimmed 222 miles, or 353 kilometres from Europa's surface, far closer than previous spacecraft, offering the chance for a direct measurement of the moon's atmosphere. Europa is like an ice ball slowly losing its water in a flowing stream. And there's another image here. I'll bring this up. VMix. Back to VMix. Where's this other image? There it is. Here we are. And I'll get my camera ready. All right. So, where was I? So far closer than previous spacecraft, offering the chance for a direct measurement. Europa is like an icy ball slowly losing its water in a flowing stream, except in this case, the stream is a fluid of ionized charged particles swept around Jupiter by its extraordinary magnetic field, explained Jamie Schwarzley, first author of the study and an astrophysicist at the Princeton University. In a NASA press release, he said that when these ionized particles impact Europa, they break up the water ice molecule by molecule on the surface to produce hydrogen and oxygen. During the flyby, JADE collected hydrogen and oxygen ions from Europa's atmosphere that had been subsequently picked up by Jupiter's magnetic field. This allowed researchers to move directly to more directly measure the amount of oxygen produced, rather than inferring it from a more distant measurements as in the past. And this image here on the screen, you can see there. In fact, my insert's in the way, isn't it? Hang on a sec. Let me just fade that out of view. Oh, I keep clicking on the wrong thing here. Where's that? There it is. Look at that. There we are. So, on the screen there is Europa is constantly smacked with charged particles from Jupiter, which might seep into its hidden salty oceans. And that's what that diagram there is kind of meant to illustrate. So, Europa holds an ocean of salt water beneath its frozen crust, which might contain twice as much water as Earth's oceans. The icy satellite is one of the prime places in the solar system where researchers think life could thrive. NASA's Europa Clipper spacecraft is slated to launch this year in October. Once it arrives at Jupiter in 2030, it will investigate whether Europa is truly suitable to support life. Well, let's hope we're still around for that to occur. Okay, thanks to astronomy.com for that one. You're tuned to ASV Radio, VK3EKH, with the regular Friday night cast. Next on the slate here. Yes. Enjoying this non-sugared coffee. Space.com. Stunning images from the Very Large Telescope capture unique views of planet formation at 1028. This is really a shift in our field of study, says the author. Stunning images captured by the Very Large Telescope VLT in Chile reveal unique insights into planet formation around young stars. And there's an image here to bring up as well. So where are we with this image? There it is. Okay. Planet, what you're looking at here is planet-forming disks in 3 regions of the Milky Way galaxy. These are real images. Planet-forming disks in 3 regions of the Milky Way galaxy. Stunning images captured by the Very Large Telescope have revealed unique insights. In these portraits, emerging planet systems look more like miniature galaxies rather than disks of debris. The figures showcase clear, defined spiral arms arising from thick dust. Others exhibit less defined clouds of luminescent matter. For astronomers, these observations present a unique opportunity to study how planets are born. The collection of images captured by one of the world's most powerful telescopes is one of the largest of its kind, framing more than 80 young stars and their planet-forming disks. And here is another image to show as well. Bring this one up. And there's some more images that they've got. This is really a shift in our field of study. Christian Jinski, a lecturer of the University of Galway in Ireland and lead author of 3 papers detailing the observations, said in a statement, "We've gone from the intense study of individual star systems to this huge overview of the entire star-forming regions," he says. "The young stars and their fledgling planets come from 3 major star-forming regions in the Milky Way galaxy. Some live in either the Taurus or the Chamaeleon 1 gas clouds, both of which are located some 600 light-years from Earth, and others hail from somewhat more distant Orion gas cloud about 1600 light-years away. The researchers found a wide variety of planet-forming disks that displayed significant differences based on which site they come from. In the Orion cloud, for instance, the astronomers observed groups of 2 or more stars surrounded only by faint planet-forming disks. Some of the most massive stars in the region had oddly shaped disks. suggesting a presence of a very large planet or planets that distort their respective disks with their enormous gravitational pulls. Some of these disks show huge spiral arms, presumably driven by intricate ballot of orbiting planets. And here's another final image to this article. A little bit tricky to make out, actually. But this is planet-forming disks in Taurus cloud, in the Taurus cloud, captured by the VLT. Planet-forming disks. So all those, what you can basically see in the image here is a nebulosity or nebula in the Taurus constellation Taurus, and you can see the little squares, little white squares. So they're all planet-forming regions which have been brought up and photographed in this image here. Quite intriguing. Others in the dataset feature rings and large cavities, most likely carved out by forming planets. Still others are smooth and seemingly inactive. More than 5,000 exoplanets, planets orbiting other stars than the Sun, have been discovered by telescopes in space and on Earth since the 1990s. Some of the uncovered planetary systems look completely different from our solar system, and astronomers are therefore still trying to figure out what factors influence the outcomes of planet forming. To observe these processes, however, is a difficult task. Regions where stars form are not only far away, but are also usually obscured by the dust. So that's courtesy of space.com, and just intrigues me the capability of these magnificent telescopes. It really is quite amazing stuff. You're tuned to ASV Radio, VK3 Echo Kilo Hotel at 10:34. Oh yes, this is an interesting article kicking around on the various news feeds at the moment. First SKA low telescope antennas deployed in Australia. 7th of March. SKA Observatory. The SKA low telescope has begun to take shape in Western Australia, with the installation of the first antennas on site today, making a major construction milestone for the SKAO. And there's an image here I can bring up. Oh, stop clicking on that. Struth. All right, there we go. This is the place to work for at the moment, I reckon. If you don't mind being away from home and out on a desert floor in Western Australia, getting involved with these guys, making these sorts of simple, you could say, radio telescopes. Pretty amazing stuff. Anyway, the article continues on, and in this image you see here the first SKA low antennas. They're calling it low antennas. I guess that's to do with the frequency. Low antennas were installed by an SKAO CSIRO team, which includes field technicians from the Warrajari Yamajai community. They are the first of the 131,072 2-meter tall Christmas tree shaped antennas that will make up the radio telescope at the Inyara Bangadara, the CSIRO Murchison Radio Astronomy Observatory on the Warrajari country. SKA Low is one of the SKAO's two telescopes currently under construction on two continents. Its counterpart, SKA Mid, is being built in South Africa. Among its science goals, SKA Low will enable scientists to explore the first billion years after the so-called dark ages of the universe. 6 countries worked together to design SKA Low: Australia, China, Italy, Malta, the Netherlands, and the UK. The latest antenna design was optimized by the Italian National Institute of Astrophysics in collaboration with CNR-IEIIT and the Italian industrial partner SIRIO Antenna. Building on previous designs developed within the international consortium, these bloody acronyms, the SIRIO was awarded the contract to manufacture the first 77,000 antennas for the telescope. My goodness me, why couldn't we have done that here in the South Dandenong? It would have been so much fun. So, SKAO Director General Professor Philip Diamond, that's a good name, travelled to Western Australia for the assembly and installation of the first SKA low antennas. Astronomers have been dreaming of this project for decades, and to see the antennas that make up the SKA low telescope finally on the ground is a proud moment for all of us, he said. These telescopes are next generation instruments, allowing us to test Einstein's theories and to observe space in more detail than ever before. With this telescope in Australia, we will watch the two births and deaths of the first stars and galaxies, giving us invaluable clues about the universes involved, or how the universe evolved. Across the Indian Ocean in South Africa, meanwhile, a similar milestone is imminent for the SKA Mid telescope, which will ultimately comprise of 197 dishes. Components for the first SKA Mid dishes arrived on site in the Karoo in February, and assembly is now underway. SKA Low Telescope Director Dr. Sarah Pierce said, "The telescopes are like time machines. We'll see things we've never been able to see in the history of humanity," she says. It may not look like other telescopes we've seen or you've seen, but the SKA Low Telescope in Australia will be able to map the sky 135 times faster than other state-of-the-art telescopes, and will be so sensitive that it can detect the faintest radio signals that have travelled billions of light years across space. How's that? Globally, 16 countries are part of the SKO's effort to build the telescopes. In Australia, the SKAO is collaborating with CSIRO, Australia's National Science Agency, to build and operate the SKA Low Telescope. In 2022, an Indigenous land use agreement was finalised between the Wiradjuri Yamji people and the Australian Western Australian governments, as well as the CSIRO. It ensures that the Wiradjuri cultural heritage will be protected, and the Wiradjuri Yamji people will receive sustainable and intergenerational benefits in areas such as enterprise, training and education. This week marks the start of on-site work for new field technicians who will be tasked with the massive technical challenge of building more than 130,000 antennas across 74 kilometres of the Murchison region. The group of 10 field technicians, 7 of whom are from the Wiradjuri community, are the first employees hired in technical roles to build the antennas on site. The field technicians will recruit to participate in a 12-month training program established by teams from the SKAO and CSIRO. The training program is intended to provide the skills they need to build the SKA Low Telescope, as well as transferable skills that will improve their long-term job prospects. The SKAO and CSIRO teams worked closely with the Wiradjuri Yamji people to encourage recruitment of the Wiradjuri employees in these roles. Professor Diamond said he was thrilled to see not only the progress of construction, which is due to be completed by the end of the decade, but also the realisation of the partnership with the Wiradjuri community. Wiradjuri community. In Australia, the Wiradjuri Yamajai people, I think I'm pronouncing that rightly, people have been observing the skies and the stars from the locations of tens of thousands of years, so to now be sharing the same skies and stars with the team is a pleasure and a privilege, he said. And I'll leave that there, I think. Anyway, I was informed a couple of weeks ago they were looking for people to go out there and be a part of this team. So, if you're not a homebod like me and don't mind tripping interstate and staying places that are out of your comfort zone, I would suggest giving Murchison people a bit of a call and see if you can get involved with this, because quite honestly, this would be pretty exciting stuff to get involved with. You're tuned to ASV Radio, VK3EKH, coming to you from the studios of VK3CSJ at 18 minutes to 11. Next article. Thanks, Brendan, too, for that link. Brendan O'Brien from astrophys.com. Okay, yeah, all right. Yes, this is good. Interesting one, perhaps. Courtesy of ScienceAlert.com. Astronomers confirm giant asteroid Apophis will not hit Earth. Just in case you were wondering if that was going to happen, there's an asteroid called Apophis. Now, I think I'm pronouncing that right. It's Latin, and I hate Latin. I just cannot pronounce anything that's Latin at all, so just don't expect me to be able to do so. But this is Apophis. Apophis. Anyway, who cares? A few years ago, astronomers ruled out the chance of potentially hazardous asteroid named Apophis redirecting and hitting Earth as it whizzes by. That's what it says. And there's actually an image here too. VMix Clint. There it goes. Righto. It's a huge relief, but we aren't entirely out of the woods. We've seen, thanks to the double asteroid redirection test, that it's possible to change the orbit course of an asteroid by smacking it with something. There are a lot of space rocks floating around out there in interplanetary space. What if one of them collided with Apophis? What if it knocked Apophis off its current course? What if the new trajectory was a collision course with Earth? All these are good questions. Well, you can relax. Astronomers Paul Wigert of the Western University and Ben Height of the University of Waterloo in Canada have projected the orbits of over 1.3 million known asteroids in the inner solar system and reached a comforting conclusion. Not a single asteroid is going to collide with Apophis in the next few years. Given how closely Apophis will pass Earth, there is a possible risk that the deflection from its current trajectory may move Apophis closer to impacting us, Hyatt says. Hypothetically, another asteroid colliding with Apophis could cause such a deflection, motivating us to study this scenario, however unlikely it may be. Apophis was discovered in 2004 and immediately assessed as a potential threat. Early projections suggested it had a very worrying 2.7% chance of slamming into Earth on its 2029 flyby. Well, that was ruled out pretty quickly, but Apophis orbit brings it to an Earth flyby every 8 years. It took until astronomers made new precise measurements of the asteroid's position during its 2021 flyby to rule out the possibility of the foreseeable future. That was great news, but there's something rather existentially alarming about the threat of an asteroid impact. There's so very little we can reasonably do about it, unless we have a lot of advanced warning, because Apophis used to represent the biggest threat in that direction. Astronomers are keen to rule out all possibilities. So Wigert and Hyatt got to simulating. Based on the current data, there's no risk of collision, they say. Apophis may pass another asteroid called Xanthus in December of 2026 within 10,000 kilometres, but they won't hit. But it's possible that any unseen debris taking along with Athanas, if it exists, could hit Apophis. Bloody Latin words. But the risk of that, according to the simulations, again is quite low. We calculate the paths of all known asteroids using a detailed computer simulation of our solar system, and the possibility of an unlikely event was evaluated. Unfortunately, no such collisions are anticipated. So all we have to worry about now is unknown asteroids, and that's the thing, isn't it? There's always one asteroid out there that we just have not seen. And how many in the last 10 years have actually grazed the Earth's atmosphere? And we hear from NASA or other people saying, geez, we didn't know it was there until it burned up into the atmosphere. So there you go. Anyway, and of course that image on the screen there, I forgot to mention, VMix, Clint, VMix. Yes. This image on the screen is a radar image of Apophis, P-O-P-H-I-S, Apophis. Radar images obtained during its 2021 flyby. Doesn't say what telescope produced that, because that's the sort of thing Arecibo used to do. Anyway, let me see. Oops, next on the article list. Oh, go back to that. Oh yes, I'm finishing up now. Okay. Courtesy of the Space Exploration Astronomical Society of Victoria's Space Exploration Facebook page, courtesy of Kate Green, who keeps releasing these amazing news articles. I think she does about 10 a day. Maybe not that much. Good on you, Kate. You're doing a great job with these articles, I tell you. Baby quasars. James Webb Space Telescope spots little giants in deep past. March 7. And I won't read the whole lot out, but I'll just do a summary. The James Webb Space Telescope has made one of the most unexpected findings within its first year of service. A high number of faint little red dots in the distant universe could change the way we understand the genesis of supermassive black holes. The research led by Jorrit Matthij, assistant professor in astrophysics at the Institute of Science and Technology in Austria, and is now published in Astrophysical Journal. A bunch of little red dots. Did I save any images from this? Oh, I did too. Here's an image from this article. Where is it? There it is. Okay. So what you're seeing there, little red dots, if you can make it out. Little red dots, an abundance of population of faint active galactic nuclei. Just go back to the top of this article. A bunch of little red dots found in a tiny region of our night sky might indeed be an unexpected breakthrough for the James Webb Space Telescope during its first year of service. These objects were indistinguishable from normal galaxies through the eyes of the Hubble Space Telescope. Without having been developed for the specific purpose, the James Webb Space Telescope helped us determine that the faint little red dots found very far away in the universe's distant past are small versions of extremely massive black holes. And these special objects could change the way we think about the genesis of black holes. The present findings could bring us one step closer to answering one of the greatest dilemmas in astronomy. According to the current models, some supermassive black holes in the early universe have simply grown too fast. Okay, and I might just leave that there because it's just going to go on and on and on. But suffice to say that the James Webb Space Telescope is keeping up to its name and its ability to find objects that we just can't normally see. So, and there it is in that image on the screen there. Really quite amazing. Again. All right. I think we can now safely go to spaceweather.com. Ooh, blind me. Okay, let's just see where I am here with this. I'll bring up the sun. There is the current disk of the sun. The solar wind, currently, the solar wind is at 498.8 kilometers a second at a density of 1.12 protons per cubic centimeter. The current disk of the sun sports 7 sunspots. 1, 2, 3, 4, 5, 6, yep. And the current sunspot number is 99. The radio sun, measured at a wavelength of 10.7 centimeters, the radio flux is 137 solar flux units. The auroral glow over Antarctica at the moment looks a bit like this. If I can find it here. Oh, there's an article I missed. And I didn't transfer that picture across. Oh, there's always something. Image. Browse. Antarctica. Open. Okay. Here it is for those watching YouTube and the TV repeater. So that's the current glow over Antarctica. So there's not much to speak about the aurora. It's very faint tonight. Only the penguins can see that. All right, now continuing on with spaceweather.com. 1 month until the solar eclipse. Okay, this is happening overseas, of course, I think. Mark your calendar on April 8, 2024. The moon will pass directly in front of the sun for a total solar eclipse. More than 31 million people live inside the path of totality, which cuts across 13 US states. Yes, we will not see it, definitely will not see it here. Millions more will travel to see the sun's ghostly corona, a life-changing sight for many who witness it. Yes. The other part of spaceweather.com, a potentially dangerous sunspot. All right, let's bring up this happening here. This little GIF image that's going back and forth in front of my eyes. What are they saying? A potentially dangerous sunspot. Don't be surprised if there's an X flare today. They say sunspot AR 3599, which is in the middle of the sun there. Has a delta class magnetic field that harbors energy for the most powerful explosions, and as the back and forth animation shows, it may be unstable. You have to be watching this carefully to see that. I'm not really sure what we're picking up on. Oh yeah, there's a few subtleties to that sunspot change, I see. But anyway, they seem to think that there might be a pretty powerful explosion come from this today in the next 24 hours, which will probably kill our radio bands. There's still no report from Tamitha. Tamitha's usually produces a weekly report, but it's normally she normally releases it like on a Sunday or maybe a Monday, and it's kind of like well over Red Rover by Friday. I'm going to have a stern word with her to try and get her to reports to correspond with my broadcast. Maybe I can get her to come up and do a live session. That'd be interesting. Anyway, so there it is. Over the past 24 hours, the sunspot has reshaped itself, rearranging its internal dark cores. Magnetic fields of opposite polarity are being pulled apart and pressed together, creating conditions for explosive magnetic reconnection. In AR 3599, if AR 3599 does explode, the resulting solar flare will be geo-effective as the sunspot is directly facing Earth. How exciting. And there is just one more thing here on spaceweather.com, which I've never seen before. Bring up an image here. There it is for those watching YouTube and on the RTV repeater. Thank goodness it's colour. What you're seeing there, these red lights are not auroras. Stress, not auroras. Last Sunday, March 3rd, a CME hit Earth's magnetic field. Surprisingly, strong impact sparked a G2 class geomagnetic storm with bright auroras around the Arctic Circle. Upon closer inspection, however, not all of those lights were auroras. Some were SAR arcs. If they had been an F. The SARARCS. SARARCS. So it's SAR, SAR, arcs, not F. SAR arcs. I'm just laughing at myself, sorry. During the storm, someone by the name of Mart Varatu photographed this red bow over Kira-Kala, Estonia, and it was a strong SAR arc. I've never heard of it before. This is the first time I have heard of this. It was a strong SAR arc, he says. SAR arcs may look like auroras, but they are not the same thing. Auroras appear when charged particles rain down from space, hitting the atmosphere and causing it to glow like the picture tube of an old colour TV. You remember that? SARs form differently. They are a sign of heat energy leaking into the upper atmosphere from Earth's ring current system, a donut-shaped circuit carrying millions of amps around our planet. A filament of the same arc was seen by Vladimir Nurish, east of Moscow, in Nizhny Novgorod Oblast, Russia. And here's his image of that. Oops, wrong one. I keep bringing up something else. There it is. Bringing it up now. There it is. So it emerged from the trees and passed right over Pleiades, right by the Pleiades, he says. The red colour was so pure. Indeed, SAR arcs are among the reddest things in the sky, with a monochromatic glow of 6,300 angstroms that comes from cosmic oxygen in the upper atmosphere. The human eye is relatively insensitive to light at this wavelength. We have a hard time seeing SAR arcs. Cameras catch them easily, though. Pro tip for photographers: use a 6300A filter, or Armstrong filter. Isn't that interesting? I've never seen that. I don't think we'll ever get a chance to see those SARCs. So very interesting. That's why I thought so. Okay, let's finish this up. Back to vMix, and I think that's about it from... Oh yes, what time is it? It's just gone 11. Because this is the International Women's Day, this last article here, and let me see if I can find it. Down the page. Here we are. Okay. Again, courtesy of Kate Green from the Space Exploration section of the Astronomical Society of Victoria. On the screen right now, you see the first Arab woman to graduate NASA's training shoots for the moon, March 6. Like her ancestors before her, Emirate astronaut Nora Alamatrushi has spent much of her life gazing up at the stars and dreaming of flying to the moon. There's more to this. There it is. This week, she became the first Arab woman to graduate from NASA's training program, ready to blast off into the cosmos. And I've got another slightly closer image. There she is, pretty lady. Mela Motorshi, I don't know how you pronounce that name, honestly. She's 30 years old, remembers an elementary school lesson about space in which her teacher simulated a trip to the lunar surface, complete with an arts and crafts spacesuit and a tent for a rocket ship. We got out of the tent and we saw that she had turned off the lights in our classroom. She had everything covered with a grey cloth, and she was telling us that we were on the surface of the moon. Wow. That day resonated with me, she says, and it struck with me, and I remember thinking that this is amazing. I actually want to do this for the rest of her life for real. I want to actually get to the surface of the moon, and that's when it all started. She recorded, dressed in a blue flight suit embroidered with her name and the UAE flag, which you can see in the image there on the screen. So bless her heart, I wish her all the best for her dreams and future aspirations to heading to the moon. I really do hope it happens for her, and she's in a great position right now to be able to do it, with the way things are moving along with the space program. Yeah, so I think that's pretty good. All right, vMix camera. Where's my camera? There it is. So, on that note, I can make a cup of coffee last a whole hour. Isn't it amazing? No packets of Tim Tams were eaten. All right, I think that's about it. So, oh yes, now, I don't have Discord with me at the moment, so I'm just going to take a word that there's been plenty of chat on Discord channel, so I really must get another computer set up here with a screen dedicated for the Discord channel. But as far as email goes, we have an email from Stephen, VK3SPX, who reports that I am 30 over 9. And we also have an email from the VCL Factor, and he says, usual large signal here in western suburbs, cutting through the butter like a knife, and something about being very technical. No stream, so it's just listening in. Yeah, no worries, Wayne. Good on you, mate. Thank you very much, Lee. Thank you for that. So let's now head across to 3541 kilohertz for any stations wishing to check in. Let me just change to a clean sheet of paper and a pencil, which works. And okay, this is VK3 EKH listening on 3541 for any stations wishing to check in.
VK3 Japan Radio. VK3 Delta X-ray. VK3 Bravo Sierra Foxtrot. VK3 KRS Victor Kilo X-ray Sierra.
Okay, we've got VK3JR, VK3DX, VK3BSF, and VK3KIS. Anybody else? Yeah, we got Ian, VK3VIN, then there was just another one that doubled.
VK3SPX.
We got you finally. All right, anybody else? Okay, across to you there, Frank. VK3JR, VK3EKH.
3EKH, Good evening, Chris. Good evening, everyone. Especially Andrew and Ian. You're very interesting. Especially the article on the SKA, which, although the article never mentioned it, stands for Square Kilometre Array. The answer didn't even just what say what it was. Bloody internet, as you say, Chris. Suppose you can hear really good, and look forward to catching up next week, okay? And if you like to wish me a happy birthday for this coming Sunday, VK3EKH,
Whose birthday, Frank?
birthday of VK3JR.
I still didn't catch it, Frank. Your signal's not very strong tonight. Bit of QSB on it. Whose birthday was it?
It's Frank's birthday, his birthday,